So how are we going to solve for x if we can't actually factorize a quadratic equation? So in other words, those are those examples when you put it into your calculator and it gives you like a weird square root or an I or something where you're just like, I have no idea to put that back into my brackets. Then we are going to use the quadratic formula. Often a hint with this is also when they say round off your answer to 2 decimal places or something like that. But in essence, we use this when we can't factorize our quadratic equations to solve for x. Let's do this example together. This is in standard form. What do I mean by that? We have our ax squared minus b, bx plus c equal to 0. So we've got our a value, we've got our b value, and we've got our c value. There we go. If it's not in standard form, you just put it into that standard form. So we've got our a is 2, our b is -4, and our c is equal to 3. Your quadratic formula is always on your formula sheet, but it's good to know it. So to solve for x, x would be equal to minus b plus minus the square root, whatever b is, squared minus 4 times a times c, and that will be divided by 2a. So now we just need to go plug in. When we see c, we'll plug it in. When we see b, we plug it in. We just need to be careful with our signs there. And a. There we have to go plug in a. So let's do that. We need to show these steps, hey? So we've got negative b. Well, b is already -4. So that's a common mistake that I see students make. So watch out for that. We are subtracting b, but it's already negative. It's -4. So that's what it means. Plus minus, and then we've got b that's being squared. Make sure that you put it in a bracket because remember, -4 squared is different than -4 that is being squared. Okay, so we're putting that thing because the whole b must be squared. -4 times whatever a is times whatever c is over 2 times whatever a is. And then you just take a quick moment and just have a squiz and see that you substituted everything in correctly. We don't want to make silly mistakes with this. Then, so this will become just a +4 plus minus. That's where we get our two solutions for a quadratic form from, right? And then we've got -4 that is being squared, which will give us +16. And let's see, what will we have there? 2 times 3 is just 6. And 6 times 4 is 24. So we'll take away 24. And that will give us 4 in the denominator. Now I can already see something interesting happening over here. See what I mean? Do you also find that interesting? So 16 take away 24 will give us -8. But that is underneath a square root. So we won't be able to actually get those solutions. There would be no real roots for these x solutions. If we simplified one step further, maybe you didn't notice that step already and you're just kind of carrying on and simplifying. So you will get to this 0.4 plus minus the square root of -8 over 4. And I guess if you then put it in your calculator, or maybe in this step, you notice that, wait a minute, we won't be able to get the square root of a negative number. It means that the roots will be non-real. They won't exist. So for this quadratic equation, there will be no real roots. Does it work like that every single time? No. We just keep simplifying until we get to our two roots. Like, for example, if you get to a point where you've got to, I'm just making stuff up now, because why not? So let's say you get to a point of x is equal to 2 plus minus the square root of 17 over, let's say it was over 5. Then you can just put that into your calculator because there we've got an irrational number, right? It's not a perfect square underneath the square root. So the square root of 17 will give us something, maybe an answer like 4,12, whatever. I don't know what that is, but maybe something like that. And then you'll just have to round off your answers. So make sure that you try one or two of these on your own and that you are comfortable with it and that you know when you're supposed to use them.